In this video, I'm covering one of the commonly used methods for calculating medication dosages, dimensional analysis. I'll walk you through the process and provide step-by-step examples. Let's get started with dosage calculations. Dimensional analysis is a method used to calculate correct dosages by converting units using conversion factors, and by making sure all the units cancel out properly, leaving you with the unit you want. It's like a unit canceling puzzle. Set up your fractions so the units you don't want cancel, and you're left with the unit you need. Here is the structure for setting up an equation to solve for the amount of medication to administer using dimensional analysis. First, you identify what you need. This is a prescribed medication. It is what you're trying to figure out how to give. Then you multiply by conversion factors, which are known relationships between units or dosages to help you convert to the correct amount. It could be the medication available or standard conversions. Solve for X, the amount of medication to administer. Here is an example. You have a medication order for 1,000 milligrams of medication, and the medication supplied is 250 milligram tablets. How many tablets will you administer? You set up the problem to identify the number of tablets to administer. First, you start with the dose that is ordered, 1,000 milligrams. You place it in a fraction over 1, 1,000 milligrams over 1. You set up the next fraction with the available medication. You must strategically place the units in the correct position so that the units cancel out, and you are left with the amount to give the patient, typically in tablets or milliliters or a similar unit. So the next fraction would be 1 tablet over 250 milligrams. You put the milligrams on the bottom so that they cancel out with the milligrams from the first fraction, leaving you with tablets. You calculate the answer by treating the problem as an algebraic equation and multiplying across. 1,000 divided by 250 equals 4. The milligrams cancel out. You would administer 4 tablets. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, 4 tablets, by the concentration available, 250 milligrams, which equals the prescribed dosage, 1,000 milligrams. Here is another example. There is an order for 4 milligrams of an IV push medication. The medication supplied is 2 milligrams for every milliliter. How many milliliters will you administer? Set up the problem to identify the number of milliliters to administer. Write out the prescribed dose as a fraction, 4 milligrams over 1. Then write the available medication in a fraction with the units set up so that they cancel out, 1 milliliter over 2 milligrams. You calculate the answer by treating the problem as an algebraic equation and multiplying across. 4 divided by 2 equals 2. The milligrams canceled out, leaving you with milliliters. You would administer 2 milliliters of the medication to deliver a 4 milligram dosage. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, 2 milliliters, by the concentration available, 2 milligrams, which equals the prescribed dosage, 4 milligrams. Always remember that when calculating medication dosages, the units of measure must be the same. If they are not, you must add a conversion factor to the problem to make them the same. With dimensional analysis, you add the extra conversion factors to the problem and include the factor when multiplying across. Here is such an example. There is an order for 1.5 milligram of medication. The medication supplied is 750 microgram tablets. The order is written for the medication in milligrams. The available medication is in micrograms, and you must convert the milligrams to micrograms. So set up the problem to identify the number of tablets to administer. Write out the prescribed dose as a fraction, 1.5 milligrams over 1. Add the conversion factor to convert the milligrams to micrograms, 1,000 micrograms over 1 milligram. Place the milligrams on the bottom of the fraction so that they cancel out with the milligrams in 1.5, leaving micrograms. Then write the available medication in a fraction with the micrograms set up so that they cancel out, 1 tablet over 750 micrograms. You calculate the answer by multiplying across. The milligrams and micrograms cancel out, leaving tablets. 1.5 times 1,000 divided by 750 equals 2. You would administer 2 tablets of the medication to deliver a 1.5 milligram dosage. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, 2 tablets, by the concentration available, 0.75 milligrams, based on 750 micrograms divided by 1,000 to convert to milligrams, which equals the prescribed dosage, 1.5 milligrams. Here's another example. The medication order is Lasix 10 milligrams PO. The medication supplied is Lasix 20 milligram tablet. How many tablets will you administer? You set up the problem to identify the number of tablets to administer. Write out the prescribed dose as a fraction, 10 milligrams over 1. Then write the medication available in a fraction with the units set up so that they cancel out. 1 tablet over 20 milligrams. You calculate the answer by multiplying across. 10 divided by 20 equals 0.5. The milligrams canceled out, leaving you with tablets. You would administer half a tablet to deliver the 10 milligram dosage. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, half a tablet, by the concentration available, 20 milligrams, which equals the prescribed dosage, 10 milligrams. Here's an example with a weight-based order. The medication order is enoxaparin, 1 milligram per kilogram, subcutaneous every 12 hours. The medication supplied is enoxaparin, 100 milligrams per milliliter in a pre-filled 1 milliliter syringe. The patient weighs 92 kilograms. You set up the problem to identify the amount of milliliters to administer. To calculate the dose, multiply the patient's weight in kilograms by 1. The dose would be 92 milligrams. Write out the prescribed dose as a fraction, 92 milligrams over 1. Write the available medication as a fraction with the units set up so that they cancel each other out, 1 milliliter over 100 milligrams. You calculate the answer by multiplying across. 92 divided by 100 equals 0.92 milliliters. The milligrams canceled out, leaving you with milliliters. You would administer 0.92 milliliters to deliver the 92 milligram dosage. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, 0.92 milliliters, by the concentration available, 100 milligrams, which equals the prescribed dosage, 92 milligrams. Here's a final example. The medication order is acetaminophen, 15 milligrams per kilogram. The medication supplied is acetaminophen liquid, 160 milligrams for every 5 milliliters. The patient weighs 154 pounds. Reading the problem, there are a couple of extra conversions to add to the equation. You need to calculate the dose because this is a weight-based order. The order is based on the patient's weight in kilograms. The patient's weight is recorded in pounds. The weight must be converted from pounds to kilograms. You set up the order to identify the amount of milliliters to administer. You have 2 options here. First, you can calculate the dose in a separate equation. That would entail 15 milligrams over kilograms times 154 pounds over 1 times the conversion factor of 1 kilogram over 2.2 pounds, which would give you the dose being 1,050 milligrams. And then you would set up the equation using the 1,050 milligram dosage. Or you can calculate the amount to administer without knowing the dose, as it is embedded in the equation. Let's set up for the second option. You calculate the weight-based dose as part of the equation. Insert the 15 milligrams per kilogram order into the equation. To calculate the dose, multiply the patient's weight by 15 milligrams. Add the weight to the equation as 154 pounds over 1. You need to convert the weight in pounds to kilograms by adding the conversion factor of 1 kilogram over 2.2 pounds to the equation. Add the available medication as a fraction with the units set up so that they cancel each other out. 5 milliliters over 160 milligrams. You calculate the answer by multiplying across. 15 times 154 times 5 divided by the product of 2.2 times 160, and your answer is 32.8125, rounded to 32.8. The milligrams canceled out, the kilograms canceled out, the pounds canceled out. That leaves milliliters. You would administer 32.8 milliliters to deliver the medication dosage. Always review your answer to ensure it makes sense. The reverse method is to multiply the amount to be administered, 32.8 milliliters, by the concentration available, 32 milligrams, based on 160 milligrams divided by 5 milliliters, which equals the prescribed dosage, 1,050 milligrams, calculated by multiplying 15 milligrams per kilograms by the weight in pounds, and then converting the pounds to kilograms. There are key takeaways when you are using the dimensional analysis method for dosage calculations. First, start with what you know. Begin with the dose ordered or the value you're trying to find. Set it up as a fraction, and that will guide your unit cancellations. Second, ensure the units cancel properly. Line up conversion factors so that unwanted units cancel and you're left with the desired unit. Third, use conversion factors accurately. Know your standard conversions. Fourth, double check final units. Your final answer must be in the correct unit requested. If it's not, recheck your conversions and cancellations. Fifth, watch for multiple steps. Some problems involve multiple conversions. Tackle it step by step. And last but not least, keep your work neat and logical. Write out each step. Avoid skipping steps. It helps prevent errors and is easier to double check. In the next video, you will find practice problems for oral medications that utilize the dimensional analysis method for dosage calculations. Thanks for watching. If this video was helpful, give it a like, share it with your classmates or coworkers, and subscribe for more nursing education content. You can find more videos at nursevideohub.com. Watch, learn, and care.